now I'm honored to very much to chair the first session of the workshop, and even more to introduce its keynote speaker, Professor Massimo Majowiecky. With his Office for Structural Engineering in Bologna, he created a remarkable number of projects, and among them we have the membrane covering of Piazza Italia, of the Fair District in Milan, the roof of Athens Indoor Stadium, the Olympic Stadium in Rome, and the Delle Alpi Stadium in Turin. Having designed more than 200 constructions, both in Italy and abroad, Majowiecky earned a great deal of expertise, which represents the foundation of Majowieck's experience-based synthetic conceptual design approach, designing wide-span enclosures from conceptual to working design phases entails facing particularly complex structural problems due to the scale effect of the loads involved. So when I was a student, I was reading a paper about the Olympic Stadium describing the structure and a bit of the design principles. Then I realized that while I knew the stadium, because I was going in there to watch soccer matches, I never thought about how it stands up. And while reading this paper, I remember I was very impressed to mention one thing, for example, by the sheer size of the structural elements. Also, as we mentioned before, I want to thank once again Professor Majowiecky for providing the very nice material, a rich document you will find on the website. And now I have some questions which I prepared to, which we prepared to have this time with him. Professor, so first thing I will share the screen and show the one of the documents you provided. This is about the Olympic Stadium and the Yaoundé Stadium in Africa. So I would like to ask, what are the differences in cost and structural performances between these two stadiums?
Yeah. Yes, well, thank you for the invitation. Good morning to everybody. And the paper that you are looking in this moment in the screen, I took the opportunity to make a parallel in time, about 30 years difference between the Olympic Stadium and the Yaoundé Stadium in Cameroon. But I took the opportunity also to present in this first conference, Italian conference on shell structure, because the Olympic Stadium, maybe nobody knows, that was the first of the family of the wide span spoke wheel roof covering stadium in the world. And then I took the opportunity to present them in Boston, and I also appreciate very much to be awarded with the first prize of this paper in Boston. Now I like to represent here in Italy, because this is an Italian construction that maybe was the starting point for many other construction around the world. And then I was interested, but at that time I have a lot of really preoccupation, because at that time I was very preoccupied about the dynamic behavior, and maybe this is the first time that we make a roof of 300, more than 300 meters with a hole in the middle. What happened? Maybe will happen something like Tacoma Bridge, etc., etc. I don't know where I found the courage at that time to do that, and it seems to me that is another one, not me, because then this is uncorrelated in time. But anyway, the spoke wheel concept like that was very difficult because, as you see, was supported vertically only by 12 columns. A lot of really a lot of particular problems in such a construction, but we succeeded to do that in 16 months, and still now I don't understand how we succeed to do that. Anyway, for Yaoundé Stadium, what is the new proposal? The new proposal is that we have a different way of erection because the so-called big lift procedure for the Olympic Stadium was much more simplified, using, you know, the bearing cable. You see the radial carrying cables there, the red one, the violet one, and this is what we need, because the only thing that we need to get the equilibrium is the angle of this carrying cable that give us give us the possibility to carry the weight of the secondary part that up there, that is an hybrid steel structure that is supported by the flying mast, the green flying mast. Then that's all we need, and therefore we simplify the system for direction, because what on the right you see the panel. The panel that has been erected all together with the membranes and so on, and then was much more easy, economic, and time consuming in the building site. Also, there is a very good safety, because you see the carrying cable, and the secondary part that you see is an arch of 3 hinges. Then it's very adaptable to any kind of tolerance in the lifting end of the ground. Then, what was possible to do? That was possible because we adopted the so-called tie-down system. That the tie-down, it means that if I, for instance, I place the panel on the tension ring, there was displacements of maybe 1 meter and more. And then in order to have a very easy erection, the tie-down system, I think there is a figure there for that, maybe. Yes, you see, maybe.
The analysis.
Yes, okay, on the left, yes, the last one on the left. You see an installation of a tie-down cable. Then the tie-down cables have a force that is more or less the dead weight, the permanent loads of the secondary structure. Then the support is in the right place, and there is not movable, because the tie-down is bigger than the permanent loads. And then with this easy way of construction, we obtain a success in time and in cost. That's all for this.
Thank you. So let me just quickly go to the second question. This is maybe something more personal, probably. Can you tell us something about your contacts during your career with Frei Otto?
Frei Otto, more or less, I was a student at that time, because I had the opportunity to meet Frei Otto in a conference in Stuttgart, and at that time I was preparing a doctoral thesis about lightweight structures, and I have a photo of the Olympic 72 Olympic Games, and then I didn't know that at that time he was removed from the design team. And then I presented my photo like a student, and he signed, but I say, I will sign reversed because I don't like anymore. this this was my only contact with Fayotto.
Ah,
A very nice person, but I didn't know that at that time was a problem because they spend a lot of time because was the first time Fayotto innovate the state of the art on lightweight structure, but the construction had a lot of spend a lot of time in the design, and then he was removed, and Venetian Partner was awarded the design. A special problem. You remember this for me.
okay. So, so I thank you for this for telling us this story. So now I have another. The next one is: does lightness of a tensile structure always correspond to low cost of construction and maintenance? This is
No, not at all. But sometimes yes, especially for very wide span enclosures. This is around 40-meter span. I think a lightweight structure is very convenient for both for cost, but for the safety and the reliability correlated to the cost.
oh, okay. Okay, and then here is another question. What can be the impact of structural details on the conceptual design of a lightweight structure?
This is a very important thing because the detailed design in a structure like this that is from the safety point of view a chain, then is you cannot have a ring that is a weak part of the safety chain. And because the lightweight structure, more of the lightweight structure are hypostatic, then they have no, redistribution of the forces if some element have a failure. Then the robustness of the lightweight structures must be obtained by the system, but not by the detail. Then the detail is very important to avoid initial collapse, and the system must short-circuit the progressive collapse. And that's why I think is very important. And then for the lightweight structure, I think also is a big part of the architecture of the system.
Definitely. Okay, so I have more. This is maybe again something a little bit more personal. Is there a structure you realized that gave you a hard time, but also great satisfaction? I'm sure the Olympic Stadium was one of these. But...
Yes, I think the Olympic Stadium remained my because it was the design that involved me in a very deep sense between the correlation between the knowledge base that I had at that time and the courage to go ahead with something really new, very big, and at that time, wind engineering was a very very lack of knowledge. And then this was the opening session of wind engineering in Italy. And I have a very, very good technical adventure with Western Ontario University, especially with Professor Vickery, that is a very big guy. And then he said me, we have no experience in subhorizontal structures, and then we have to gain knowledge on that. And together, he gave me a little bit of confidence about something that I will always remember: the aerodynamic damping. He said, "I think you will be helped by the air, the moving air."
I see.
And then the stability of the dynamic stability. Okay, this is you know, design adventures.
Okay, very, very good. So the next one is what is, in your opinion, the peculiarity of the Italian school in lightweight structure in the last 40 years?
You see, I remember when and I'm speaking about the 1969, when I approached to have a doctoral thesis about that. Yeah, I was in a place in Italy dominated by the concrete structure. Even the steel teaching, steel structure teaching were not open at that time, even in Bologna. There were only few you know, teachings, maybe in Torino, in Milano, but you know, this was a country dominated by the concrete. Well, we passed from the heredity of Nervi, Morandi, Musmeci, and Musmeci at the last time he tried to initiate, you know, the school of the minimal surfaces, then the bubble surfaces, the membrane and the membrane. But he have done a membrane structure, you know very well the famous bridge of Sergio Musmeci, and that is a reversed, not the temptation to do a membrane, but is a membrane under compression. Because was reversed in shape, and something like was done at that time also in Spain. Somebody like the architect Gaudí, he made trying to make something according to the minimal surfaces. Then the membrane concept that was initiated at that time. And from Sergio Musmeci, yes, something has been done, and I hope you will continue. You are the younger people now. I'm very satisfied that in Italy we can follow and open and continues the lightweight structure concept.
Yeah, let's hope so. Yes. So that was the last question, and we are all very thankful, and especially thankful for this nice chat we had this morning, and it's very instructive for all of us to listen.
Okay. Thank you very much. Thank you very much.
So
maybe we can ask if there's one question from the
there is
audience.
time for one more question. Yes, if
some...
somebody has one quick question.
Sure.
Yes, Mauricio Cardenas. You can switch your microphone.
Can you hear me?
Yes.
Yes.
Massimo, I would like to know which is your favorite classic structure from classic architecture from the past.
From the past.
Yes. And why?
And why? Because when I was in the Venice University, yes, I really appreciate you know the cupolas and because I say, well, it's incredible, and these people that can do that without any computer, and then cutting a stone that have three meanings. This is a stone that is engineering static, architectural for the shape and the mystic of the cupola, etc. And also a sculpture, because the stones were cut inside like a statue, etc., etc. And these people have the possibility to cut perfectly one by one, and then putting all together and realizing, you know, these master builders. And I have in some of my conference, I also show a photo, a statue of that time, because a master builder make his face. He left the sign by a statue of himself. No, he's in 1379, and then I was really impressed about this guy and all the other guys that have done at that time that. Now, from here, we are in the other side. And then in the structure, we have like in philosophy, yin, yang.
Yes.
Yes.
And then, but everything is in the middle. In the middle, we have something that we don't understand. That is the plate, the beam. That is something completely hybrid, but also exists. In reality, is only the deformation of the two, the yin-yang, deformation, and then it's something that we call a plate or a beam or something like that. Okay.
Okay.
Thank you.
Time is up. Thank you again, Professor, for staying with us.